So, um, just because we're keeping this short, I'm not going through a big intro of the company at all, or even a small intro of the company. But this is just kind of a quick intro of just some of the fun things that we do. So our company got started on structural engineering, but with structural engineering being good at that, they got into vibration analysis, and then being good at that, got into acoustics and noise control as well, and testing and monitoring and all that kind of stuff. So this is more on the structural side, just one of the fun projects we did. Unfortunately, it no longer is open, but for a little while, there was an indoor go-kart track at the Mall of America called Smash, and we engineered their ramps because they were really worried about these electric go-karts that were going only 40 miles an hour and then smashing into a ramp to go up or smashing back down. So we actually did finite element analysis modeling for structural engineering on this, and actually built spring isolation into the ramps and engineered this whole thing. It's one of our engineers, and actually engineered this whole space to be able to work with go-karts smashing into it. It worked really well, and nobody's complaining about noise, so it was really fun. Just running through these kind of quick. Structural engineering, this is a strong wall, strong floor system that they designed for the University of Minnesota. So huge testing facility for huge forces that they're applying to different materials. Just we do vibration monitoring, so light rail transit, something that we've had to do a lot of work on around the Twin Cities. Also a lot of work in clean rooms or hospital type spaces, noise control, vibration control, all of the above really in these kind of spaces. But some of the fun projects that I've got in this presentation, we were the lead acoustic and noise control engineers for the state capitol renovation that went on a few years back. Done a ton of light rail around the cities. That's been kind of interesting. Generator noise control is a really fun projects, at least in my mind, because it's really, really loud noise sources that you have to try to meet certain criteria at nearby spaces. A lot of multifamily projects, hospital projects, and then I've got some bad vibration isolation stuff in here. I don't know if I'll get to all of that. I'll probably only make it a little way through the presentation, which is fine. These are just kind of some fun ones just to look at. But this is our state capitol in Minnesota in downtown St. Paul. And the two spaces that were the most interesting in there are our House Representatives chamber on the left here, and then our state senators chamber on the right here. That's me making a measurement. But there was a lot of work in here. So HVAC, it was controlling all of the noise from all the HVAC systems. They had rooftop units that were around and different fan-powered systems that were hidden behind all this ceiling, and then lengths of ductwork that would go to supply air diffusers or return air grills and all these spaces. So controlling the noise from those. Room acoustics was insane in here because it is a huge space and it is curved surfaces and it's all hard surfaces. So they're all saying, oh, it gets so loud in here, we need some sound absorption treatments. It's like, oh, okay, what one of these beautifully ornate surfaces do you want to give up that we can cover with an acoustic material? Oh, none of them. Okay, so you want us to change the acoustics but do nothing to your space? Yes, absolutely. Oh, okay. that doesn't happen. So, we talked about a bunch of different options. We even went, and asked, what if we did like a perforated plastic material in front of it so you could at least see through it? Like, no, we don't want to be able to have anything obscure. It's like, well, okay, then you get nothing. So it was just controlling expectations. One of the big issues they also had in this space is cocktail party effect. Unfortunately, they don't have very good manners in our House of Representatives, and they all talk over the top of each other. So it gets really, really loud in there. Like, hey, can you help us reduce the noise in here? Well, it's not the noise per se. It's this cocktail party effect that everybody keeps talking, and they keep talking over the top of each other, and it gets louder and louder and louder in there. So they wouldn't let us change the sound absorption in the room, so we couldn't change the cocktail party effect in there. It was more of just making them aware, hey, by the way, you guys are the ones that are causing this. It's not the room. Part of it was also speech intelligibility. They've got a little speaker here. They did hire an audio engineer that came in and did a new audio system where they put column line array speakers in the front that would more put the sound right at the listeners, and did help improve the speech intelligibility a little bit, but their poor behavior in there made it still that it wasn't as good as they wanted it. Another interesting aspect of these spaces is just the sound focusing. It's a big circular space, and one really interesting thing is that they have this point up in the middle that they call the speaker's well. And what they thought was going on is anybody could stand in this spot and speak right up front, and then everybody around the whole space would hear them. And that's actually not true. That's not really what was going on. What happens is if you stand in this spot to speak, your sound goes up and it hits all of these curved surfaces and it's focused right back at you. So you stand in this spot and you hear yourself really well. But nobody else around is going to hear you any better. Fortunately, you're pretty close to everybody, so they probably just thought you were getting amplified, but really you were just hearing yourself better. But it was just kind of a funny occurrence. And we actually had a guy in the Twin Cities area who has this big stop sign device that can put out sound, and then it'll kind of detect where the sound sources are coming from. So he could kind of map the highest noise levels were coming back from these different surfaces. And we could actually show that, yes, these arch surfaces and everything is where the sound was coming from. So it was a useful tool to be able to show the senators and the representatives, here's where the sound is coming from. If you really want to do anything about it, we have to treat these surfaces. Well, they're the most ornate surfaces in there, so they weren't going to do anything with them. But again, it was just kind of educating them on how the spaces were performing. So that was a fun project. Light rail is a big part of what we've been doing for many years around the cities. So some of the spaces that have been the most critical are recording studios. So light rail is put up right next to local newscast studios. It's put up right next to condos. So here's a condo tower with townhomes and 30 feet. I mean, these center lines are very close to multifamily spaces. This was an office building in downtown St. Paul where they were going to run the line right outside, and this was like one of their major conference rooms where they were concerned about it. So we actually put our noise monitoring system in the space and monitored noise for a month and monitored vibration, and they were worried about, I think they had their data center in the building as well, so they were worried about vibration affecting their data center. The biggest client though for us has been NPR. It's kind of fun living in the same city areas where NPR is, because they do such great things with music. Two of their best studios, they call them their world-class studios, are Studio P here, and then also Studio MMW, the Maud Moon Warehouser studio. Just beautiful, huge studio. People like Yo-Yo Ma come here to record their CDs. So, but part of these amazing part of these studios is that they've actually got windows that overlook the street, and on the street down below is right where they're going to put this LRT. So they're worried about all that bell noise and any of the vibration from the LRTs coming up into these studios and making them not so world-class anymore. There's going to be all this disturbance. So one of the interesting things that we did in there, was long process, but one of the fun things that we did there was using our Gross low noise microphone system and actually making low noise measurements in there. And it was really fun to go in there and actually make negative decibel measurements, where here's our 0 line, and in the MMW, this is Studio P, everything above or around 1,000 hertz and up was all negative decibels. And in Studio MMW still we had some negative decibels too, but I mean here it's 17 dBA for both the L10 and the LEQ noise levels. The L10 is normally quite a bit higher than the LEQ, but in this case it really wasn't. It traveled really pretty close to it, so there wasn't much disturbance in this space, basically, is what it was kind of pointing out. Same thing in the MMW. So it was really hard working against the government that literally wants to railroad their systems through, and trying to come up with a criterion of, look, if your LRT system is going to cause any kind of spikes in here, is that going to be acceptable, and what are the causes, or what are the repercussions going to be? So it was a very long process, but pretty neat working in these amazing spaces to help work through these issues. Generator noise control, this was just a small one, but this was a plot that we put together for outdoor noise, where on the left here we're looking at a generator that's at this plot and worried about all the noise going to the residential homes nearby. At the property line, for nighttime we have to meet 50 dBA, and we've got these yellows which would indicate over 70 decibels. So just if they plopped it out there, it wasn't going to work. But we do our noise control, and we can show them, look, if we're trying to keep everything 50 dBA or less, okay, well now we've got our 50 dBA curve down below once we apply all these noise control. So always nice to give them some visual aids to kind of show how, yes, this could be bad. We'll do some things to make sure that we get it under control. The
Ryan, on
one,
that project,
yeah,
were those like, is that simulation or is that
no,
measurement?
it's a calculation, and the calculation just you put in your sound source and then put it on the plot to say we have this noise level here, and it's having to go around, this barrier of the building or around this existing water tower where it has to bend around. And thanks for jumping in, Lily. I didn't mention at the beginning. Anybody that wants to talk or raise questions throughout, feel free, because yeah, I don't need to just hear myself talk. Anybody want to bring up anything is more than welcome to. But
Did
yeah,
you all ever validate any of that then? Or like, is that part of like,
it's always nice when we don't have to, because that means that nobody's complaining. So anytime we have to go validate, somebody's paying for our time. So the nice part of our job has been that we almost never hear from our clients afterward, and it's because it went well. It's like if something goes well, they don't want to bother us. They don't want to pay for our time to do anything else, which is kind of nice. If we hear from somebody, it's like, oh, what's wrong? Which doesn't happen very often, fortunately. Usually it goes well. Um, but we have on occasion gone out and validated for some really sensitive projects where the city was really worried about the issues. And it is surprising how well it usually works out that, you say your generator noise source is some sound power level, you apply sound insertion loss for your different sound noise control items, and come up with calculations to say what it should be. And we've gone out, after projects are complete and made measurements, and it's amazing how we'll be within a few decibels of the criterion. So it ends up working out really slick, but not too often that we actually get the opportunity to go out and validate, unfortunately. Be fun to do it more. This one was just really fun. We had a client that would do gas turbine generators. So these giant, turbine engines that are crazy loud, but they're used for creating power in emergency settings, but a lot of power. And so they have really high air filtration requirements. And so they have, well, being a turbine engine, it takes a lot of air. So these giant houses, basically, that are just all these levels of air filtration. But then they give us this section in here that's a silencer. And so we do calculations to say, okay, we know this jet engine basically is this crazy loud. And if it goes through the duct, through our silencer and out this hood that we know we've got some sound insertion loss that we get for all these air filters, we need to meet some criteria of 80 dBA out in front of it, or some criteria 50 dBA off at a resident nearby. But these silencers end up being huge, where it's 27 feet wide, 10 feet long, and 17 feet high. So I mean, they're the size of a barn. I mean, they're really giant silencers. So it was really fun to engineer these silencers to perform right, where we're changing the baffles of these silencers. Silencers is a big box with baffles. Like air can get through them, but it attenuates the noise as it goes through this 10-foot length of silencer. And so we engineer what the baffle dimensions had to be and how many to put in the big bank of silencer to be able to make it provide the sound insertion loss that we needed. So those are always really interesting. Yeah, this is another really interesting one of this is a 2 megawatt generator. So huge generator. They were going to put 3 of them in this room in downtown Minneapolis. And so tons and tons of noise. They gave us this whole tunnel all the way through the building that we were going to pull air through. So we ended up creating kind of a labyrinth path where we had like wall and then a wall coming down from the ceiling and another wall. So the sound had to kind of go up and down to get through the tunnel over here to block noise. I engineered this labyrinth here where the sound had to come back over the top of the generator and out and around and then get to this louver over here to get outside, because across the street was potential residents, and a residential receiver, you have to be 50 dBA. Well, we've got this generator that's producing like 120 dBA. So getting all that noise all the way around here, attenuate enough of it that it went outside. And same thing with the discharge exhaust. So they got the exhaust coming off the thing, and they wanted to point it right at the building. I'm like, please don't point it right at the building. That's the worst thing you can do. Can we at least like point it up so that we get the directivity going up? Nope, it's got to go straight out the building. Okay, so we got these crazy reactive silencers, that's chambers in there. But the way generator engineering works for sound, you can't use more than one reactive silencer. Otherwise, they start talking to each other. and you get resonances, and it can actually be where your sound level at some tone is worse with 2 silencers than if you just had 1. So we use a really good reactive silencer and then also an absorptive silencer, which is just a straight pass through with perforated metal on the outside, but insulation around that. And that got a combination of those 2 got us enough sound insertion loss that when it was pointed across the street, it worked. But it's really funny now, they'll run the generators out this building and you can go stand on here and you don't even know that they're running except for this cloud of exhaust smoke coming out of the exhaust pipes. So it's fun that it worked really well. Looks like we've got a couple minutes. I don't know, do you want me to go through any more of this, or does anybody else want to ask questions?
I have to get to an exam, but thank you. This was a very good presentation. Yeah, sorry.
No problem.
Hey, Ryan, I also have to jump off for another meeting at 2:30, but I will see you tomorrow in 10:10, and this was a really great presentation today, too.
No
Thanks.
problem.
Thanks, Lauren. Thanks, Tori. Jared, Kenton, do you have any questions, or do you want to have a glimpse at the remaining slides, or what are you all? Or Drake, sorry, you're off my problem.
We're missing
I'd love to see the rest of it.
Yeah, I'm down to watch the rest of it. I'm interested.
Okay.
I have a 2:30, but thank you so much, Ryan. It's so good to see you. I hope you're doing well. Super great information. And unfortunately, tomorrow I have a thing at from 9 to 11, so I'll miss your morning presentation too. But I advertised it to my class, so hopefully you'll get a lot of smiling faces on the Zoom.
Sounds good.
Okay, bye-bye,
Nice
guys.
to see you. Okay. Well, I don't know if you guys want to go past, we can. But I don't have to either. It doesn't really matter.
I think if you're interested, I think this would be great. I think it's always fun. Jared's nodding. Yeah.
Yeah, I'm definitely interested.
Okay. So this is just a couple of apartment projects. We do a lot of multifamily projects. That's actually, if you catch, well, I had a presentation last winter. I'm gonna have another presentation for this winter ASA meeting, and it's related to multifamily stuff that I'm doing a lot of work on. This is just a couple of towers that we worked on downtown Minneapolis. The Nick on 5th is in downtown, and this is the 4 mark. And a lot of work that we do with this. This had LRT as well, going right down the street past here. So they were worried about the bell noise, from the trains being bothersome, and it is. All we could really do is let them know that, hey, these trains are going by. It's going to be noisy. If you want to do anything, you can change your glass, but it's really, really expensive to do that. So probably don't want to. And of course, they didn't want to, but we made them aware. We also look at traffic noise going in. A lot of times the biggest issue is buses, because there's a lot of buses going through downtown. It's low frequency noise, and the low frequency noise wants to get through those windows a lot easier than other sound does. What's interesting though is if your facade isn't all glass like some of these are, where if you got walls, everybody's like, well, all the noise is coming through the windows. And it's actually not true. So a lot of times when it's low frequency noise, you get a lot of that noise coming through the wall as well. So when we're doing our engineering, we're evaluating the wall and windows, and sometimes we have had some projects where we've had to increase sound isolation of both the windows and the walls to make it work properly. HVAC noises are constant with these. You got giant makeup air units and exhaust fans up on the rooftop that make a lot of noise, and you don't want your penthouse people that are spending tons and tons of money to be up on the top level getting peeved off because they got HVAC noise down coming from up above them. Actually, it's kind of funny. This was another one of our projects where they've got this giant penthouse air handling unit here, and people at the Nick on 5th were complaining about the penthouse noise coming over, so we had to do noise monitoring on a balcony over here, figure out that, yeah, they are exceeding the code requirement, and then we engineered some silencers to go on the top of these units to reduce the condenser fan noise, because the condenser fan is pulling air through coils for cooling that would be used by the systems, and the condenser fans are just slapping the air. They're really not engineered to be silent by any means, and so we had to engineer some silencers to go on the top of these units that wouldn't exceed the static pressure requirements, because those condenser fans are not very efficient and they don't pull air very clean and neat. So you can't put a silencer on there that's going to make it that they can't pull air anymore, because they can't handle that. So it had to be a pretty open system to block some noise, and we were able to do that we got them below the code requirement there. So that was kind of an interesting one. AC units was actually kind of a boring thing. They were worried about that the whole building facade is basically have holes in it because every individual apartment has its own air conditioning unit. So they were worried about if everybody turns on their air conditioning unit at once, is there going to be tons of noise coming off the facade? We did an analysis of it and it wasn't that bad, but it was just something they were concerned about. Apartment sound isolation is what takes us up the most time. We're looking at all the walls, what wall types do they use, how does sound get around the walls, you know, if they don't do their wall terminations properly, does it leak? And floor ceiling assemblies, how much impact noise and sound is going through your floor ceiling assemblies. And that's the big thing that I'm working on right now with my presentations at ASA and the work that I do at the ASTM, the standardizations group. Is related to the impact noise going through floor ceiling assemblies. The part that I'm really concerned about is the low frequency noise. That these buildings aren't so bad because they're concrete, but you get into the wood frame stick built buildings and your floors want to deflect as you walk on them, and that deflection creates that low frequency pressure wave that radiates from it. You experience that in any kind of house you're in. If somebody's walking in the wood frame, or if you're in a low level or a not too tall apartment building, you got people walking on the floors above you, it's going to be a stick frame, and that's going to produce low frequency noise, the boom, boom, boom noise you hear somebody's walking across the floor. And so we've been doing work to try to evaluate that noise. Is there ways to mitigate it, and what's the best way to evaluate that? Other interesting projects are just hospitals. We love what,
do you use accelerometers in those studies?
You know, we haven't. It's really, so the work that I've been doing has been doing on trying to figure out how to evaluate it either with a tapping machine is one method, the standard tapping machine. We really don't like, from what we've done engineering wise, we don't like the tapping machine. And if you catch the presentation I do in December, it's going to talk about that. The ones that I've done previously talk about that too. But the hammers just really aren't big enough to put enough force in the structure at low frequencies, and you see that in the results, how it just tails off in the low frequency, the really low frequencies, down to like the 20 hertz low range that we can hear. What we like to do is use the impact ball that was developed by Tachibana, the big 5-pound ball, and drop that on the floor from a meter up, and that actually excites the structure in a way that's repeatable and can be well evaluated. So that's what we've been doing.
You're measuring like airborne noise with sound level meters and stuff. Do you actually use accelerometers all or maybe Tony will know, like, does in his work, does he have to measure like the vibration in the structure? And I asked that because Jared and Kenton are taking an independent study on vibration measurement right now. And so I thought we would.
Yeah, ask questions of Tony tomorrow, because he's really our vibration expert, and he's going to give the majority of the presentation tomorrow because he's our real vibration expert. And he's not on the call, so I can say it out loud without embarrassing him, but he's really, really good at vibration. It's impressive what he can do with vibration systems. He's not here, so I can say this, but somebody oftentimes will have, like, where we're competing on vibration projects where, it's a big deal, there's some really big problem, and somebody will fly in their expert, and then Tony will be the local guy working for somebody. He's critiquing the experts from other places on, no, don't do that, that's not going to work. I mean, he's really, really good at doing vibration measurements, so feel free to bug him with any kind of questions you have. Yeah, the hospital project, this is a hospital project we did with AECOM. They got us involved with this hospital in Qatar, Doha, Qatar. That's the Sidra Hospital, and this thing's just massive hospital out there that they built. But it was looking at lobby acoustics, because they had this like 3-story lobby in there, trying to make sure that it wasn't going to be crazy loud in there. They had an auditorium where they were going to do presentations. If you can't read this, neither could I. This was their mechanical systems. So they had mechanical systems everywhere, and the ducts were running all over the place on top of each other. And like, this is an air handling unit, and this is an air handling unit, and the ducts are all over. So trying to figure out, yeah, I bend your head, it's crazy. So trying to figure out the noise control for that was a beast. One of the fun things that we like to do work on, though, is like the MRI systems, where we're worried about vibration from the MRI bothering other spaces, and we're worried about vibration from other spaces, like footfall vibration affecting the imaging of MRIs. And then we're also looking at the noise of, these things create a lot of noise. Here we got 109 dBA inside of the MRI room, and we have to worry about the noise going into adjacent spaces, whether it's, you know, spaces above, spaces below, or off to the side. You know, a lot of times we'll have like a hallway that's right next door. So there's, you know, sensitive space like this is saying we wanted to get to NC 30 in some space right above the MRI. So it's putting in ceiling systems that would get us there. These are images from the National Children's Hospital they worked on in DC. They put a, oh, I'm not going to remember the name. It was an MRI, and I'm not going to remember the name, but it was this combination system where it was an MRI where they'd have it right next to, in this children's hospital, a room where they'd be doing surgery. So they have some imaging capability, but then they pause their surgery, push the patient through to the MRI, scan them, look at the scan, put the person back in the surgery room, and they could go back and forth. It was really, really neat system. Yeah, there's the bed that they'd be on. This is the control rooms that were next to the surgery room and the MRI room. So this was the space before it was finished, where they've got this giant mass of concrete that they tried to isolate to have the vibration. This is Tony's setup with computer for vibration monitoring and measuring. And then this was my part of it, of looking at the noise from it going through this giant block of concrete that was here, down to spaces below, through this random path. It's sometimes really hard as these existing buildings, they get these weird paths. So the concrete, the concrete only went so far, and then there was just a little bit of a floor, and they had to worry about the sound leaking around the mass to get down to spaces below. Oh, that's got the name on it. Angiography. So that's the name of this room, the angiography room. Couldn't remember what it was called. But upstairs, I hate these spaces. I know they're really, really needed, but NICUs are my least favorite because I always made fun of the structural engineers in college because I'm like, you guys want to engineer systems where if you do your job wrong, somebody could die, like your building falls apart or whatnot. I'm just doing acoustics. My thing's not going to hurt anybody. Until NICUs, then I get really nervous because NICUs, you got to control the noise so that you don't have, excessive noise that's going to go to a space and actually injure a baby. I heard a bad story about a 4th of July party that went on up in, where was it? It was was it in Canada? That couldn't have been 4th of July if it was Canada. They must have fireworks somewhere. But it was near a hospital, and they blamed the fireworks show for killing a baby that was nearby a window. It's like, I don't like that. I don't want to be messing with. So I'm very careful with NICUs when we're doing noise and making sure. I mean, you can see the system of ceiling that we put in here. It was just really, really built up ceiling assembly and still had, a concrete floor up above. So we were doing a lot to try to block the noise from going up and over the top of this space. Bad vibration. This, unfortunately, is a very regular thing that we do, but this was a really interesting one where we had 3 chillers up on top of a condo in downtown Minneapolis. And we had people that were living, it's the rooftop, so these are the penthouse condos up on the top level of this building, and they were complaining about the noise from these things. So now we're looking at, well, is the noise going through the concrete slab itself of the roof? They've got skylights. Is the noise going through the skylight? Is the noise bending around and going through their balconies? Well, no, it wasn't any of those things. What it was just vibration from the structure that was coming down and vibrating and radiating from all the surfaces, and as well as the pipe. The pipe would come off of these units, and it would come down the posts and into the structure and radiate as noise that way. The hard part was that their existing was they just had coil springs. I'm not going to take the time to go into it, but just if you want to look up something later, something to look up would be surge frequencies. You can actually get your springs to vibrate. They're resonant at some frequency, and it's called the surge frequency. And the chillers have variable frequency drives on them, so they'll speed up and slow down. And at some frequency, they line up with the frequency of the spring and that surge frequency, and it just sings coming down through the post and gets right through. So we engineered a option to put rubber in between there to isolate how much rubber, or how much of the vibration got into the spring, and then also still try to reduce how much of the vibration got through to the posts down below. Another option is to use air springs. These aren't going to have that surge frequency issue, but they're really expensive. They're hard to install, and then they have to be maintained too, because it's air that's compressed into there. So you've got to either have some kind of a system that measures, if the air is inflated enough, or you have to do it manually where you check them, and it's really kind of a pain in the butt. But, you know, here's our system that we put in with all the extra rubber. And, you know, before we had this really bad tone at, I think it was 315, if I remember right. It's showing at 400 here, at 400 hertz. And then after, we got it to be almost right down with the background noise level. So it worked, but it's kind of an interesting, difficult one.
I was going to say something about those air springs, which is like, it just reminds me how I never put air in my tires in my car. My husband hates it. He's always like, your car feels terrible. And then he'll take it. And sure enough, my tires are like completely. Well, so I can imagine I can't even maintain my tires, like much less maintaining some air springs.
It doesn't happen. They get ignored. Then we've gone to sites where it's like, oh, we've got air spring isolation. Everything's fine. And we go look at the unit and smash. Nobody's these air springs in forever. It's just metal to metal contacts. Like, yeah, that's not working. So they can be a real pain. Work really well if you maintain them.
Do those like the temperature, like winter versus summer, affect those at all? With, like
so
the air density?
Worry about that was actually a big deal with that NPR project with the light rail trains. We were working a lot on isolated rail system out in front of the buildings. That portion of the rail would be on some kind of a vibration isolator to reduce how much of the light rail train vibration was going to get into the ground and then up to the studios. And that was one of our concerns, is for rubber systems, it's affected by temperature. It hardens with cooling. So in Minnesota, obviously we got really cool temperatures. Is the rubber going to get to where it's so hard, it's providing a lot less vibration isolation than what was intended. I haven't seen that with the air systems, because with the air, I think it's been enough of a movement that they don't really freeze up. But with rubber, it's something we have been concerned about. The fortunate part about these is these systems were only running during the summer, so we didn't have to worry about the rubber freezing. What we did have to worry about was sunlight. We were worried about whether it was going to be deteriorated from the sun. And so we actually did put little sheet metal shields on these just to reduce how much they were exposed to the UV light. So these are some chillers that were also in a penthouse above condos that people were complaining about. And so they put, all they had on these chillers that were up in this penthouse were just some little sheets of rubber that were doing almost nothing. And so, you know, we had somebody's bedroom that was right below, and all the vibration was just coming right down. You know, we looked at, could it be these different airborne noise paths, but it really wasn't. It was just this vibration issue, that all the vibration was coming straight down to this condo. So this was a Tony mastermind thing that he did. Chillers are kind of a pain to isolate because they're not a very stiff structure. And so all they ever want to do, like the chiller manufacturers, all they ever want to do is just put rubber under them, because you can put a continuous layer of rubber and you get continuous structural support. Well, now we want to introduce some kind of point structural support. Now it gets these eccentricities, and the mechanical guys are worried about that their equipment's going to fall apart because it's going to be moving in ways that it wasn't supposed to, and now it's going to break. And so what Tony had to design was this frame that would go all the way around the chiller and keep the mechanical unit evenly supported the whole time. But with this beam that came over the top, they could now have a place to put these air mounts, and then they could just lift it up just a tiny little bit. They actually ended up leaving those little rubber things in there because they weren't doing anything anyway. But they only had to lift it up a tiny bit just to get the clearance so that it was off of the slab, and then it worked. There was, the vibration issue was gone, and the residents down below weren't complaining. But residents did complain later, and they found, hey, they weren't maintaining the airbags. So they just had to lift them up again. So unfortunately, they are a maintenance headache, but they work really well. Hey, those were the main things that I wanted to get through. So that's just the last thing. For any of you that don't recognize this bowl, this is the mascot from back when I was in school, before the new logo.
I think it is still that bowl, or maybe there's a newer front.
There's a new bowl that I hate. It looks like the University of Texas bowl mixed with our Mav. It's kind of odd.
Well, thank you so much, Ryan. You have any more questions, Drake, Jared, Kenton, or things that you...
I'm excited to see your presentation tomorrow.
Yeah, Tony will be giving the majority of it. I'm just going to be around just to be able to support. But yeah, he loves doing the vibration stuff. So I mean, I think he's got some interesting stuff that he wants to chat about.
That's great. Well,
I did my undergraduate all in structural engineering, so this is all super interesting to me as well.
Oh, there you go. Cool.
Yeah, and I think that's why we're also excited about the UNA ASA talk tomorrow, is that we were trying to get some of the structurals interested in coming to the talk too. So, well, thank you, Ryan. Thank you so much. I appreciate you taking this time today. And thank you, Drake, Jared, and Kenton for staying extra long. And thanks for letting me record it. I'm going to stop that now. And yeah, because like I said, there were some